In the next portion of the DVD, we're going to concentrate on building a facial rig for this character and do it strictly through bones instead of using the morph system that we did for the first one. I've gone ahead and actually built all of the bones because this is a pretty straightforward process and it really doesn't need explanation on how to put bones into place. But what I'd like to do is cover right now as to why I've put them where I've put them and what they're expected to achieve where they are. Again, we're going to start with a jawbone that's going to basically handle all the main jaw rotation up and down and side to side, and even a little bit of twisting if we like. I've then carried a circle of bones around the mouth, one from one side, and you can see where it starts and stops, and then on the other side, just mirrored it over using the bone mirror system in here in the bone tools, so that we don't end up with mirrored bones. And in this character, I've also followed one around sort of that line that comes off the nose down around the chin, because that's such a big flexible character, this character's face. How you end up doing this for any given character is really based on what you need out of the character's performance. You can't say that this specific setup is going to be exactly the same for every character. A character has a very thin face, not a lot of sort of fatty tissue on his face, might require a completely different way of addressing it. So you can see that I've carried it around there, and again I've mirrored it over to the other side. And then what I've done is I've radiated it out from the mouth area, out along each one of them, and basically this is to create sort of a muscle flow direction. So when the mouth opens, it'll squash this joint. We can skin to this as well as the ones right around the lips. If I pull these a control that'll be here, let's say, it would squash this side, it would stretch these out and pull them, it would stretch this one out, and we could get sort of a nice muscle tissue sort of feel around the face, nice flexible face area. I've carried separate bones all the way around and underneath his jowls as well. Now, one of the nice things about this is this character's got quite a soft, fatty, tissuey face, and this should probably be doing a little bit of jiggle and bounce when the character moves. In this case, what we'll be able to do is use something like a spring controller on the joint here and get it to do a little bit of flexy motion, and here as well, let's say, and underneath in the middle, and actually get this joint to bounce a little bit and bounce and flex a little bit. What I'll do is I'll just turn on bone edit mode, and you can see sort of where we'll go at is this will be able to bounce and flex here. We'll be able to even do it here if we wanted, and have something like this. So you can see that we're getting this nice flex on 4 different axes, in a sense, 4 different directions around the face. And again, we can do the same out here. We'll have a control that handles the movement of the face. Let's just go to screen mode, and we can stretch and be able to flex it on all angles. So we should be able to get just about everything we need out of the mouth. Now you might want to, again, if it's, depending on how much complexity in the face shapes you're looking for, you might want an extra bone or 2 around the mouth in areas, and even possibly radiating out so that you can get more flexibility in the mouth. We should be able to get a fair amount here, because we should be able to get a nice sort of lip curls up and down. Of course, the corner of the mouth will be able to flex out. So we should be able to get a fair amount of control out of this character. And same thing with the bottom lip. We should be able to get a fair amount of control going, and in the top and whatnot. Around the eyes, similar sort of setup. What I've got is around the bottom of the eyes, around the top of the eyes. Around the bottom of the eyes may not be quite as needed. You might be able to use it and be able to get the when a character smiles, be able to push this up and help push up the fatty tissue underneath the eye. But then, for sure, with the eyebrow, we need to be able to control the eyebrow, be able to bend and flex this to be able to get what we're looking for. The eyelids as well. What we're doing here is we're setting it up so that we've got 3 joints, top and bottom, for the eyelid. This way, we can actually get a lot of bend and flex out of the eyelid. So we'll be skinning the edge of the eyelid to these. Now what I've done is I've snapped them to the center of the eyeball so that they pivot right around the center of the eyeball, so that when we skin to the bones, it'll pull down the eyelid around a bit of an arc. Now, we may also need a second row or just a single bone just to hold the outer ones in place a bit more, something to skin off to. That could even be the bone in the head possibly. If the eyes were really large and bulbous, we may even need a complete second row of bones that were very much like these, but rotated 50% of what these ones do. So we'll have to try that out and see what we get with this character, see if we can get away with less bones than just simply adding more off the bat. We're also going to have a bone up the nose, and this is kind of nice because characters like this, quite a big soft nose, and what we can actually do is be able to animate the nose stretching, flexing, and moving a little bit with the tip of the nose as well, which is quite a nice feature in it. I may actually add eventually some bones going up into the brow area as well to help squash some of this brow area when his brows raise a lot. Again, it's one of those things I think I'll just leave until the point which I see that what I've got isn't working, and then I'll go ahead and add them later. Easy to add later. The controls at that point really don't change. Now, this sort of face system that I've set up is requiring a lot of bones, a lot of stretchy bones as well, and therefore isn't necessarily completely game friendly in its current implementation, because most game engines, or no game engines that I know of, actually handle stretchy bones at this point. Can't see why they wouldn't be able to, but it's whether or not they need this kind of flexibility in their joint systems. It also is incredibly complex what I've got set up compared to what you'd normally need in any kind of game facial animation, and usually a lot less bones are needed. I've set up several for games, and it requires no more than sometimes about 4 or 5 or even less. 3 bones I've seen in a facial animation, depending on what they need to do, and of course more than that as well, depending on again what the game is actually requiring. You usually have to avoid the stretchy bones though, and you can do it in several different fashions. But this one should allow us a fair amount of flexibility. So what we're going to do is we're going to take it from here, and we're going to move on and start setting it up. So basically, for the first step, what we have to do is we have to turn these all into stretchy bones. Now, they already stretch, but what we need is sets of controls, basically in the form of point helpers to control all of these. Now, what this means is essentially setting up the stretchy bone system that I use for muscles, which requires us to have a point helper at the beginning of a bone, one at the end, have the bone position constrained to the one at the parent end of the bone, and then looking down at the one at the child end of the bone, and the one at the and then the up node of the look at set to the one at the parent end. This is a lot of bones to do this to, and would take a lot of time. So what we're going to do is we're going to write a simple script, and we're going to make it really easy for us to set up. Now, I've already written it, but what I'm going to do is I'm just going to use this as a reference to write the next, so we can reference back and forward. You can see what I'm actually doing. So let's start a new script here, and I'll show you how to get around this a little bit to make it a fast and easy solution for you. Again, this is one of those scripts that can be reused and reused. We're going to write a function. A function is just a block of code that we can reuse. Make stretchy bones, and we wrap it in a set of brackets, and we write our code inside. Now what we're going to do is we're going to create point helpers for each of the currently selected joints. Now the way we're going to write this is going to be really simple. We're going to have to pick one chain at a time and run it on one chain at a time. You could do it other ways, but the code of course would become, you then have to start writing more and more error checking to check which points go with which objects, and how everything should relate to each other, and it could just become more code than you need to write to speed your life up. So we're gonna write it quite simply. And what we're going to do is we're going to start with an empty array that we're going to collect the points that we make for each chain of bones. So that's this right here. Basically, we're going to call it points, PTS, equals, and we're going to make an empty array that we're going to as we build the point helpers, we're going to throw them in there so we have a collection of them in order. Next thing we're going to do is we're going to loop through all of the joints in the current selection in order, and we're going to create a point helper for each one, and we're going to align it to it so it's all they're in the right spot. Now this also again is going to require us to make sure that we select the joints in the right order. You can't just go and select them in any order like this, because it would probably make quite a mess of it. You need to pick them in an order, and again that's just a matter of double clicking on the root joint and having it pick down the chain, and it'll set it all up for us. So the next thing to do is to loop through it, and we're just going to use for X in selection do, and we're going to create point helpers and append them. So I'm just going to copy and paste this out of here just to make it real easy, and then just describe what we've done. The command point will create a point, and then you can send the parameters to it. Now what we can do is we can actually check and see what all those parameters are real easily. One, you can check the help file. Two, we can make a point object and find out what the parameters are. So let's actually just run this one line of code. I'm going to go Shift Enter on that line of code, and you can see it put a point helper right here. And what we're going to do is in the listener, we're going to say show and $sign for the currently selected object, which is that point helper. And what it does is it shows us the different parameters that we can pass to the point as we build it. And so we've got size, center market, axis, tripod, cross, box, and you'll notice those correspond with what is in the modify panel by default. So we have some of those added in here. We've got center marker false, axis tripod false, cross false, box, so it's just going to show up as a box. And we've set a wire color to it, so each one of these is going to be a specific color. In this case, they're going to be red, and so that we're going to sort of color code all our point helpers, because by the time we're finished this rig, we're going to have a lot of point helpers. We're going to have point helpers on top of point helpers, and it's best to color code them so you sort of know which point helpers are being used for which things. So the next thing the code does then, and by the way, it makes the point helper it makes a variable to hold that point helper while it's working on it. It then sets the transform of the point helper to be equal to the bone that we're looping through. So as we loop through, X becomes equal to the first thing in the selection, first object, and it builds the point helper and then makes the transform, so the position, rotation, and scale equal to that of the bone. So it's going to pop that point helper right to that bone. And then it appends this array and adds the point helper that we've built into this array, and it's just going to fill this array up with any of the point helpers that we've made. And so the next step, go back to our rig here so we can see it. What we need to do is we need to create, in this case, the setup of constraints. So what's going to happen is each joint gets position constrained to the point helper that was built and aligned to it. So we're going to start with another loop. This time we're going to use a different type of loop. This is an iterative loop, and we're going to go with the indexed loop. And this indexed loop says for X in selection do, for I equals 1 to selection.count do, as opposed to for X in selection do. We don't actually need this set of brackets. I think I changed a piece of code earlier when I was originally writing it. And then what we need to do is we need to set up our constraint. We'll start with our position constraint. Just to make it a little bit easier to write all of this, first thing I set up is I just make this the object that we're getting access to, so the bone that we're getting access to, equal to B, just to make the rest of it easier to write. So for I equals 1 to selection.count, so selection I will be equal to each iteration of the joint, as the bones as we go through them, and they'll become equal to B. Essentially, they'll be represented by B. The next thing we need to do is we need to make a position constraint, and what we can do is we can make an instance of the position constraint, and I'm just going to say poscon equals position constraint. And if I evaluate this, positions, so position constraint, posCon is now equal to a position constraint. It's not on any object, it's just simply an instance of the node. And so what we can do is we can find out more information about posCon to find out what we can do with it. So first off, we can use show posCon. Show posCon. And if we use show on it, we can get the weight of it and whether it's relative or absolute. Now, what we really need is we need to find out how to get access to adding the constraint objects into it and how to set the up nodes. Again, consult the help file is probably the best way, but just so you know, you can also go show interfaces with a lot of things like this, and it'll actually give you the commands. And if you understand how the basic command structure of Max works, this is often all you need just to get at the help, in a sense, for the position constraint. I know these are the parameters I can pass to it and set it up. So in this case, append target looks like what we want. So posCon.append target, and then the node that we are actually trying to append to it. That'll be the one that we want to constrain to. And then it's looking for a weight. So this would be the weight of that given target, because you can have multiple targets in a position constraint. We're just looking for one here. We'll just set it to 100. So what we can do next is we can actually say, well, let's do, let's go to the next step. Let's say b.position.controller equals the position constraint. So we can actually just add the position constraint to the bone. And then the next thing we want to do is set up the targets for it. So posCon.append target and PTSI. This is the reason I've used the indexed array, is because I want to actually use the index not only to loop through the selection of bones, but also to loop through the points that I've generated ahead of time. So we know we have 1 point for every bone in our current selection, and they're currently lined up. So the first bone in the selection has a point that is equal to it, that is lined up to it, and that's the one we want to constrain to. So posCon.append target, the first point in this case, because it would be the first bone in it, the first time it's going through, and then the second joint and the third joint and the fourth joint, so on. And it's going to have a weight of 100. So already if we ran this, what it'll do is it'll actually set us up, and I'll just go back down and just do it down on the ground plane down here. I'll say make a bone chain. We can run our piece of code. I'll just double click on those, and I'll just grab this whole chunk of code inside here and make sure we don't get any errors. It looks like we've got something passing an error to us, but it made all the point helpers. It'll line them up, and it looks like it's actually added the points to it, and you can see that it's set them up, but there's no look at constraint on it, obviously. I'm just going to run that again just to make sure that we didn't get an error, and that was just a mistake on my part. Oops. Let's just run that part, and that's okay. And then this section. So it is okay, actually. It didn't throw an error. I thought it did. I saw red in the listener, and that's always a bad thing. So now we've got the position constraints set up. You can see that the joints don't stay pointing at their children. We need to set up look at constraints now. Now the trick with the look at constraints is that we want this joint to look at this point helper, this joint to look at this point helper. We don't want the end one to look at anything, so we actually only want to set it up in the first two. So what we're going to do is we're going to use an if statement here and set it up so that it doesn't go to the end one. So I want to say if I is less than selection.count then. So in this case, selection.count would have been 1, 2, 3. And sorry, I left an extra one there. What we want to do is we want to stop at 2. a value of 2. So as long as it's less than selection.count, then go ahead and run this next piece of code. Doing this a little bit differently, I made the look at constraint up here. In this case, what we can do is we can actually make it right inside the if statement. Probably better over here, better way of setting it up. So I'm going to drag this over. Same thing as we did up here with the position constraint. I'm going to create a look at constraint. Just make an instance of it into this variable so that we can just work with this variable instead of having to constantly list all of the paths down to the controller. What we can do is we can just work on this this instance of the controller that we generated. Again, let's just do a evaluate that line so that look at con is global, and we can do a show. And there's, when I run show on the look at constraint, here are some of the things that we're working with. A few things we need to look at is look at vector length. When Max adds a look at constraint, it puts that big huge blue line that goes on forever. I set that to 0 right away so it doesn't show up. And the other one that we're going to need is upnode world. We want to set to false, and that's using the world as upnode. What we want to do is we want to actually set that to false, and we want to pick the upnode, and we want to set the upnode to be the actual point helper that's at the root of the joint. And then the next thing we want to be able to do is show interfaces, and we need to be able to do the same thing. We need to be able to append the target and the node. So it's exactly the same format for using a look at constraint. It is the position constraint. So on to the adding it then. What we can do is we can say b.rotation.controller equals look at con. And then what we want to do is we want to set the look at con parameters that we need. And I'll just, again, I'll copy and paste this out of here. So what we've got is we append the target. So we set a target. Again, in this case, it's going to be not equal to I. It's not going to be the first one. So if we're working on the first joint, we're not looking at the first point. We're actually looking at the second point. So what I've done, again, this is why we've done the iterative loop here. Index loop, is that what we can say is that the append the target points, and instead of the point that is equal to the joint we're on, we're going to say the joint plus 1. So we're looking at the next point as what it goes, so it looks down to this one. And again, a weight of 100. And then look at vector length. And so to use this, it's just look at the controller itself, the look at controller. Dot look at vector length equals 0. That makes that blue line 0 in length. And then upnode world equals false. So we want to use something else. We don't want to have the upnode set to world because that would mean our character could rotate around a world space, and the joints in the face would not rotate with it. Essentially, they'd twist wildly out of control. And we want to set the pick upnode to, again, back to points just I instead of I plus 1, just I. So that's back to the one at the root of the joint again. So now we have is this nice little script for handling our stretchy bones. We should be able to evaluate this whole piece of code, and it won't give us any errors, hopefully. Let's just do it, and you just say it comes out okay. And let's grab this and just delete it again, and let's make a test joint. Select all of it, and we should be able to run make stretchy bones, and it should set us up with a set of point helpers. And if we rotate any one of these point helpers, it'll actually twist the bone. And then when we move the point helpers, they'll actually stay looking at each other and give us stretchy bones. So there's our stretchy bones script, set up very simply and reusable. Now all we need to do is we could just simply create a macro script using this function that calls this function and make sure this function is always loaded in the scripts startup or in the std plugs std scripts folder, which will actually load first. And we could drop it there, and it would be available to us by either command line, just typing this, make stretchy bones, and close parentheses, and it would run it on whatever whenever we have selected. Or of course we can make a button bar out of it and go that route. So why don't we actually do the button bar for this case. I've got a button bar that I use for dropping stuff on. I'm just going to grab this command and drop it on here and just edit the text and stretchy bone. And now I've got a button I can press and have it set up the stretchy bone for me. So now I should be able to go back to our face and go through the process of adding stretchy bones everywhere. So I'm just going to double click on the root, say stretchy bones, and then I've got the setup of point helpers all the way around, and I've got a stretchy bone set up. And if I set up another bone like system like this one, stretchy bones, well, you'll see I've got 2 point helpers here, and again those will eventually get parented into probably a third, maybe even a fourth, to get alignments correct. But now when I move both of these, I get the nice stretching going on. Same thing with setting up all the way around here. You can see that once I pick these two, again I'll have a nice stretchy system set up. So just like when I was grabbing the bones directly, but now it's from the point helpers themselves, and they'll all stay aligned. What I can do is eventually all these will get either parented off to either other point helpers, other control objects, and wired expression into the controls and whatnot to be able to control the face. So I'm going to go ahead and I'm going to finish setting up all the point helpers on the rest of them so that each one of them has a stretchy bone set up and isn't parented to anything, and I'll take it from there when I get back.